Hello, happy Friday, everyone. Happy morning to some, happy evening to some, happy daytime to some. It's very confusing because half the world is an hour ahead. We're still behind. I'm in the UK, so it's 4 p.m. here and it's normally 5 when we do these. So it's all been very confusing in my head. But I hope everyone is good. Great to have you here. And we've got Hamza joining us today, and we'll just give a couple more people a chance to come through the doors. Anyone who wants to write on Slack, anything crazy that's had happened to you today. I had my next door neighbor's dog escape from my garden like 5 minutes before this call. I had this like moment of like, oh my God, what am I gonna do? Thankfully he wasn't that far, but he's a dog that does a runner. So anyone's got any last minute like, oh God moments, do chuck them in the chat because we'd love to hear about them. Um, cool, we've got loads of people joining. Excellent, excellent. And Hamza's just finishing her scone quickly, getting a bit of extra energy in before she starts. Um, okay, cool. All right, great. Well, I'll just give a bit of spiel about Irrational Labs for those that don't know about us. So we are Irrational Labs. Welcome, everyone. And we have worked with hundreds of organizations through sort of behavioral science, behavior change, behavioral design to help them think about how they can bring the behavioral design approach into their processes. So we've worked with lots of different companies, big and small, a lot in the tech field, more and more so. We were born from the BE unit in Google a long time ago now, and we've since then done hundreds of research studies. We're all about understanding the impact of what works really well from our different interventions that we do. And we've also trained thousands of people inside big and small companies on behavioral product design through workshops, but also through our cool boot camp as well. So that's a little bit about us if you don't know us already, and I'll do a little bit more at the end. So these are just some of the people that we've worked with. I'm sure you'll recognize some of the big players there. But now, more importantly, I want to introduce you to Hamza, our wonderful Hamza. So Katie, one of our managing directors, saw Hamza do a talk a few months back and was wowed by her and thought we have to get her in to do one of our talks to tell us all about what she is up to. So Hamza, she is an assistant professor at the Wharton School of University of Pennsylvania, where she studies how artificial intelligence, particularly generative AI, is reshaping human learning and decision making. And her research combines behavioral science, large-scale field experiments, and computational methods to understand when AI truly augments human capacity and actually when it risks undermining the deeper thinking and skill development, which I think is an area that we're all trying to grapple with. And her work has been widely recognized and is helping shape how we design AI systems that support rather than replace human intelligence. So really topical, and we can't wait to hear all about it, Hamza. So what we'll do today, guys, is we will share with you, I'm going to share with you a Q&A document. So if you've got any questions, rather than them getting lost in the chat, which by all means go free for like write whatever you want in there for a bit of conversation. But we will have a little document, a Q&A document, where I will share with you in just a second, where if you can just write your question in there, and then at the end, we'll go through them in order, and hopefully try and get through as many of them as we can. So that's Hamza Bastani. Hamza Bastani, I'm gonna pass over to you, Hamza. I'm gonna stop sharing my screen and let you take the reins.
Hi everyone. Thank you, Rosie, for a very kind introduction, and thanks to Katie as well for setting this up. Um, like Rosie said, I'll just do a little bit of a spiel for a bit, tell you about some of the work we're doing on human AI collaboration and how to make sure we actually support humans thriving rather than replacing or undermining them. And then I'd love to open it up for Q&A and hear your thoughts. This is based on joint work with a bunch of people, only some of whom are named here, but Oscar Bastani, who's at Penn CS, Angel Chung and Stefanos Polides, who are PhD students who work with me, Gerard Cashon, who's in my department, and Alp Sungu as well. Let me see if I can start it. Okay, so I think generally the way us from social science we think about technology is in the lens of human capital development, where performance broadly interpreted as us as a society is a function of the technology that we have access to, as well as the human skill that actually wields this technology. And so generally in the beginning, when Gen AI first kind of came out, and we all started playing around with ChatGPT 3, if you will, there was a sense that as technology improves, performance can only improve, but that's under the assumption that human skill kind of remains constant. And what we were interested in back in 2023 was, is that actually true? Because you might worry that as technology improves, the human skill actually atrophies as a function of the technology as we start over relying on this technology. And then you might get this paradoxical kind of result where as technology is improving, human skill is kind of decreasing. And so overall performance as a society is actually going down rather than going up. And so we wanted to test this, and we wrote one of the early papers about how generative AI can actually undermine learning. We ran this study and we came up with it in 2023. We ran it in 2024, and of course, it's published in 2025, so it's a slow process. But we basically just went into a high school, which served about 1,000 high school students in 9th, 10th, and 11th grades. We didn't want to touch seniors because they were preparing for a university entrance exam. And we gave 2/3 of them laptops. And we said, hey, it's time for you to, we're doing practice for a math class. And so we basically randomized them to either having access to a GPT-based tutor or having access to just their lectures and notes. So business as usual in a classroom. And we wanted to understand what are the impacts of them using GPT to practice math problems on a subsequent math exam. And at the time, there was a lot of excitement about these LLM-based tutors because people are like, it can personalize, it can increase access to information. A lot of students don't feel comfortable asking for help, and so they should just be able to ask these things instead, and it will lower the barriers or frictions to access to information. But what we found was actually not so straightforward. We found that students that actually practiced with ChatGPT without any guardrails, just regular ChatGPT, actually did 17% worse on an exam they took right after without AI assistance. And this was sort of consistent. We had them do this 4 different times in the same math class for different topics. And so they didn't kind of learn over time that this was bad or anything like that. They just immediately performed worse. And the mechanism was kind of very simple. The first question they always ask is, what is the answer? It's like it's the predominantly first question that you get. And often that just basically completely undermines any kind of productive struggle or learning. And so we immediately see this effect of like people getting, worse and like learning worse and having less skill. We did find that if we had guardrails in the guardrails in the system prompt of the LLM, that actually mitigated this harm by forcing students to engage, but it still didn't help compared to just using lectures and notes, because even though lectures and notes are kind of like inefficient, and we all kind of recognize that, it helps create this productive struggle that's essential to information retention. Like friction leads to information retention, and anything that undermines that kind of harms learning. And generally, we're starting to find, like, I actually co-direct the Wharton Healthcare Analytics Lab here. And we generally find, as we work with the Center for Health Incentives and Behavioral Economics, or like a bunch of other organizations about using these chatbots for helping patients make decisions, engagement is a challenge, right? It's not just about learning math. We care about people, being more informed and making better decisions. So to lay it out more specifically, we want to achieve that, we have these chatbots out there. Our goal is that people really comprehend what they're grappling with. So like in healthcare, the diagnosis, the symptoms, the different treatment options, and so on. And then they can actually use their preferences and engage in some sort of shared decision making. So maybe I want to get pregnant next year, or maybe I have a limited social support system. And so, there are various things that inform your choices about your own health. And then we want to help them close the behavioral loop, right? So you get this information from the chatbot. Hopefully you engage in like actual conversations, and then you use that to make actual for decisions downstream. And this has generally been a challenge, because what we're seeing is much more of this crutch behavior where people ask these one-off questions. They just ask, what is the answer? What should I do? And then we don't see sort of follow-up from that. And that's kind of the gap that we're trying to plug, is to help people take more charge and be able to do better, to thrive with this information, rather than to use that to replace the effort that goes into shared decision making. So it's kind of tricky when we're talking about looking at large language models because the ground is shifting under our feet. So we can't really think about equilibrium behavior or things like that because these models are getting better every year. There's also this huge novelty effect that people are very excited about large language models and using ChatGPT. And so I think it'll be a couple years before we can really start looking at equilibrium effects. And so we thought, why don't we look at chess? So chess, Garry Kasparov used to be the world master, and he actually in 1997 lost to Deep Blue, which was from IBM, this deep neural network that actually was finally able to beat humans. And he has this famous quote that I was really the first knowledge worker to have my job threatened by a machine. And so this kind of is like a useful model for us to go back and take a look at to try to understand what the impacts of AI are on human decision making, human learning, and their own agency. So chess is also nice because it's kind of well known that using AI can help you learn, but can also become a necessary crutch, kind of like this over reliance effect that I just mentioned in math. Garry Kasparov has a quote saying, "Engines have made us stronger, but they've also made us lazier." Magnus Carlsen, has been the current reigning champion, world champion, says, "I try not to use them too much on my own because having some engine knowledge can be a lot worse than having no knowledge." So it's this kind of interesting thing where like humans have become much better at chess after AI sort of solved chess, if you will, because now there's a lot more information that we can learn from. There are all these new tactics that we can learn from using these AI models. So they're incredibly powerful and potentially very useful. But at the same time, we're seeing these risks that a lot of people actually can get a lot worse because they undermine their own capability by over relying on this technology. So it's sort of this double-edged sword that you have to be very careful about using. And this is exactly what we wanted to study. And the other thing here is that the incentives are aligned. So when we did our study on math students, those students didn't really want to learn math. That was kind of very evident during the study. They had no interest in getting better combinatorics other than being able to do well on the exam. So chess is kind of different because the students that are in the study, they really want to play and they really want to improve their game and they want to beat their buddies at chess. So it's kind of a nice model. Okay, so the thing we studied was something we call system versus self-regulation. I think that's been the real shift here, is that as we're giving these personalized AI chatbots to everyone on demand, nowadays we choose how and when we consume information, whereas before there was a person in charge who chose how we consumed information. This is true everywhere. In education, a teacher chose or your tutor chose how and when you would get hints. In healthcare, your doctor or physician or healthcare provider chose how and when you would get information about your diagnosis or condition. And now you are getting to choose that, right? The flow of information. Oops, sorry, I'm having a lot of trouble with my PowerPoint. Self-regulation, on one hand, is theorized to help learning by increasing people's agency and their engagement, right? Because now you're in charge. And so in principle, you should be more engaged and want to put more effort. But people have also shown things like the Kruger-Dunning effect that it can harm learning because low-skilled people actually are more likely to be overconfident. And so they might actually harm their learning because they think they've already learned something that they haven't quite learned yet. Where I'm going to argue against both of those effects. So we basically did this, and by we, I'm being very generous to myself. Stefanos Politis was the PhD student who ran this study. You can see him over here. He's actually a ranked chess player himself. I'm actually terrible at chess. We ran this pre-registered experiment with 216 chess club students in Greece, Cyprus, and Kenya, and we basically randomized them in this three-month chess intensive training program. Everyone got placed into the chess intensive training program. The age range was 8 to 58, so anyone who was interested in kind of spending a lot of time playing chess after hours and with a coach. But half of them were under 18, so these were largely kids, and you can see they're very excited about their stickers. We got parental permission for all this information. We ran them in a 12-week intensive training program with coach involvement, and we gave them basically like these fairly large cash prizes, $10 to $150. The average was about $40, and again, there's actually like a currency conversion, and so this is a reasonable amount of money for them. based on their engagement and their performance on chess games, both on the platform with AI assistance and then afterwards without AI assistance. We also financially incentivize the coaches so that they would actually follow up on their training so that we would actually get strong engagement on this platform so that it was a meaningful intervention. And it was designed to it was gamified and it was designed to be a lot of fun. And I think generally they enjoyed it regardless of the arm they were placed in. And this is what the platform kind of looks like. It's AI-enabled chess training, like accelerate your chess training with the aid of AI-generated tips. And then the platform, I think, is actually still available, and some of the kids are still playing on it, even though there's no financial incentive anymore. And so when you log in, you get individualized credentials. You pick your color, you pick your time, whatever, and then the students basically get randomized to either getting a system-regulated platform or a self-regulated platform. So I'll show you what that looks like in a second. So in a system-regulated platform, so for those of you who haven't seen a chessboard, this is a chessboard. In a system-regulated platform, the algorithm basically takes a look at the position that you're in, and it tries to infer if one move is kind of much better than other moves. And this is formalized using something called a value function. So if there's one move that will increase your odds of winning a lot more than other moves, then it will give you this tip that basically says there is an optimal move here. That's it. Okay, that's the whole AI assisted help, and it kind of automatically looks at the board and tries to figure out if this is a position where there is a really, really good move. And if it's like enough by a certain number of centipawns, then it will tell you that it will give you this message. And typically it hits for about 20% of positions or something. If you play the optimal move, so this is a very simple optimal move. You just have to take the queen. Even I found it. It'll say you found the optimal move. Good job. And so it kind of like reinforces to the student that they did the right thing. If it's a more complicated board position like this one, I actually didn't find the optimal move. So I played the wrong move. It'll say something like, no, you didn't find it. Knight h5 was the best move. And then it tries to give an explanation on why it's the best move. And it also tells you what the sequence of play might look like from this position a couple of moves forward so that the student kind of can internalize and understand why this was the right thing to do and what game path they missed. So that's system regulated. Self-regulated is identical to system regulated. So we have exactly all of these ingredients in there. But in addition, we just add one button. And so that's this little blue button over here. And it says, get a tip, right? And get a tip basically says that a player can click this button at any point if they're stuck. And it will just tell them, the best move and the explanation that I showed you. If you didn't find the optimal move, it'll show that to you on that position. So like if I'm stuck here and I know there's an optimal move here because I was told that, and I can't find it and I'm getting frustrated, I now have the option to press this button and then it will tell me the best move is bishop to g2. It has a bishop fianchetto, which I don't know what that means, but apparently it's good. And then this is what I can do, and this is the sequence of moves that will be good for me, right? And the students can always choose not to use this button. And if they don't use the button, they're basically identical to the system-regulated condition. All we have is this one little button. In terms of the UI, that's all that changes. And so I actually, when Stefanos ran the study, I was like, there's just one button. This is a very expensive study. Like, are we going to see any statistically significant effects? I thought we were going to see a null. But actually, it turned out that system-regulated players improved more than twice as much as the self-regulated players. So just having that button over there during the study over this 3 months basically meant they learned half as much as their friends that didn't have the button, right? Which I thought was crazy. So if we look at training games on the platform, system-regulated players, these yellow bars are actually, self-regulated players, the yellow bars are actually winning more. That's because they have access to the button, so they can always ask for the answer, and so they actually win more games. But if we look at the test games where they're playing without AI right after, they're actually playing much worse. And so they've learned half as much than their counterparts compared to the beginning of the study. And we find that this effect is actually not based on skill, kind of like the Kruger-Dunning effect, but rather based on motivation, right? So we don't see any difference between the students that had a really high ELO versus a really low ELO. What we see is that the students that were really motivated before the study, the ones that spend many, many hours per week training on chess, they actually even seem to, they weren't harmed by self-regulation or having the button there. And some of them at the very top percentiles were actually benefited because they would learn these tactics that they didn't know about before and then apply them in future games. But most players, your typical median player, is hurt a lot based on if they have access to the button. Um, and if we look at it, the answer is actually quite simple, just like our math study, is that the button reduces productive struggle. So like I'm stuck, I don't know how to win this game, but I really want to win this game, right? And now I have an out. I can always just click the button and I know that it's gonna tell me the answer and then I can change the course of the game. It's ironic in this case because what's really sad to me about this is that 30% of self-regulated players before the study actually said that they were worried that these move reveals would undermine learning, and more than that actually suggested similar effects. And at the start of the study, like in week 1, we actually see that they ask for very few tips. I think because of this, because they know that it's going to undermine their learning and they want to get better at chess. But as the study progresses over the course of the 3 months, they just keep asking for more and more and more help, and they just can't help themselves. And to me, it's like a lot when I'm trying to be on a diet and there's cookies in the house and I just can't stop eating the cookies. And then, it goes downhill. And the only way I can really stop myself and commit to it is if I remove all the junk food from the house. So I don't actually have the option to collect it, right? So having the button there is just a constant reminder that you don't have to struggle at this moment and you have an out. And that's very, very difficult to avoid because it's a conflict between our long-term and short-term goals. Long-term, I want to avoid over-reliance. I want to learn. I want to be an amazing chess player. But short-term, I just want to win this game and I don't want to, keep struggling anymore and I want an out, right? And this is like a classic failure to self-regulate. And I think this is what we're seeing a lot with AI use. Yes, it is powerful. Yes, it is useful and informative, but it's very difficult. The problem is actually the human part. It's very difficult for us to actually engage meaningfully and actually struggle with the problem than to just kind of use it as an easy out. But obviously, the latter is not a useful, is not a valuable use of AI. And we actually looked at, so in education, there's this idea of students' zone of proximal development. This is the area in which the problem is neither too easy that you should just, delegate it to the AI, or too hard that I'm never going to figure it out. But it's in that like ideal window where I can figure it out, but I have to kind of work hard and struggle. And we find that really the whole mechanism here is that finding out the moves. Oops, sorry about that. Finding the moves within a student's ZPD is what harms learning. So they're actually asking for help exactly in the positions where they could learn the most if they struggled, but they didn't. And so that's actually pretty much most of the treatment effect that we're seeing. The other sad thing is that they also engage less. So it's just when you have self-regulated learning, because you have the option to ask for answers, over time it just becomes less fun for them and they just play fewer games, even though they're getting the same incentive scheme, the same financial incentives, the same leaderboard and gamification. We find that they just don't enjoy it as much because, having help kind of takes the fun out of the problem. And so we find that at the end of the study, system-regulated players, they want to train with system-regulated AI. In fact, like I said, some of them are still using our platform well after the study ended. But self-regulated players actually said they prefer to train without AI. They were like, we should be playing in real life with real boards and physical pieces. And we think that's not really, if that's also a nice effect that you can touch the pieces, but we think what's actually going on is that it's kind of taken the fun out of the game. So what are the implications for human AI collaboration? I think generally this is kind of a big challenge that often if we look at the literature, we all know or we kind of all feel strongly that human AI combinations should sort of be the most powerful. But if we look at the literature, it's swamped with examples where either human only or AI only outperforms human AI combinations, right? So either the AI is not very good at this task and then humans are just better, or the AI is pretty good at this task and then, the AI is just better. Which I think as we're moving into generative AI is not an acceptable answer because we have to all kind of grapple with being able to work with AI together, or we're going to, sort of not achieve or unlock the benefits of this technology, right? Oops. And so we actually built a game theoretic model to try to understand, is this sort of a rational response, or is it just something, is it a behavioral effect? And what we find is that it's actually a very rational response because AI creates something called moral hazard, which is that if you know that an algorithm is going to give you the correct answer 99% of the time, and you are hired to check the 1% errors, now you have to put effort 100 times to find one mistake when you could just not put any effort and then, just take the pay hit when it screws up 1% of the time. And that's actually what we find if we build a game theoretic model of a firm hiring a worker. This is called principal agent problems in econ, to complete a task with AI assistance. We find that even when human AI collaboration is sort of first best or optimal for the system, if we didn't have any information asymmetry, because we can't observe how much effort people are actually putting into human AI collaboration, the firm is better off either doing like three all bad options, I think. One is banning the AI completely and forcing the human to work alone. This is what we see a lot in a lot of schools, right? Like we're seeing teachers kind of say we need to do in-person exams without any AI assistance, and this is not a great solution. Or they will just fire the human, so it's too expensive or too hard for me to monitor the human. Anyway, they just end up shirking effort, so we might as well just, use the AI directly. Why bother having this middleman? Or they might reluctantly adopt human AI collaboration, but then there's all these paradoxical consequences where they actually prefer a less reliable AI because it's just easier to make sure that the human is putting effort if the algorithm is actually correct less often, right? So if the algorithm is only correct 90% of the time and it's wrong 10% of the time, you're much more likely to check all of the time. If it's right 99% of the time, now you really don't want to check because most of the time your effort is getting wasted. And so this is sort of an unfortunate depiction, but this is just what comes right out of the math. So some of these effects that we're seeing, they're not even irrational. They're sort of natural consequences of the economics or incentives that we have available. Let me move forward about trying to say something positive, because I feel like I've just gone 20 minutes saying all negative things. So we do think there's a potential for these technologies to be used in a positive way. This is a paper that we actually just posted on effective personalized AI tutors via LLM-guided reinforcement learning. And what we think is actually a really useful source of information are the human LLM or the human chatbot interactions. So far I've said, we don't know if the human is putting any effort. We don't know, like, are they just asking for the answer? But actually we do know if we look at those chat conversations themselves, right? And so what we did here was in this paper, we basically tried to build a rich understanding of the student state or their mastery of the problem that they were working on to decide what to do next. And so I'll talk about this for the next couple slides, but just to foreshadow the result, we gave students kind of personalized homework problems over 5 months using their chatbot, the human student chatbot conversation, and we found that we actually could improve their test performance, their unassisted test performance by a significant amount in a Python certification program. So this was actually a large-scale collaboration with the Department of Education and Taipei City Government, the American Innovation Center, Wharton, and Penn Engineering. And the government basically announced this Python certification program for high school students. It's part of their AI literacy and bilingual education policy. And so we got the opportunity to kind of come in and build this custom platform for them. So in July 2024, we did a little pilot. I'll show you the platform in a slide. And then we basically met with teachers and students and parents to recruit students into the certification program. It got launched in January 2025. And then we did this 5-month study basically from February to June and spring of 2025. And so these are the results I'll be talking about. And it was we recruited, I think, 1050 students across 10 high schools in Taipei. 2 of them were private, 8 were public. We saw similar effects regardless. And out of these, about 300 of them were seniors, and so they had to take an accelerated program, and so they're not part of the actual analysis. We're going to be looking at a subsample of about 770 students that I'll be talking about. So this was sort of the grade mix. A bunch of them were first-time learners or beginners, and a bunch of them were intermediate. I'm going to sort of ignore the proficient or competition level students. That's a very small fraction of them. Competition student level students obviously shouldn't be taking an intro Python course. They're already winning competitions, but about half are beginners and half are intermediate, I could say. Okay, this is what the interface looked like. So there's a teacher dashboard, there's a chat bot, and this is in Chinese because it's in Taipei, but we can show some things in English, I guess. So basically on the top right, there's like on the top left, there's like a video for like the course videos. On the bottom, there's an AI assistant based on ChatGPT that has a bunch of guardrails built in. So that's like your chat tutor. On the top, on the top right, we have practice questions. And then on the bottom, there's like an editor, a code editor, where they can try typing in, like implement this for loop or while loop, or here's a multiple choice problem, and they can solve those things and they get feedback on whether they solved it correctly or not. And students were required to do at least 15 practice problems per kind of homework or module. We generated questions based on GPT, and what we found was basically that looking at the code edits the students were doing in real time gave us a lot of information on whether or not the student understood the topic, right? Like, are they making edits? Are they making meaningful changes between getting the problem right or wrong? What kinds of questions, the chat quality, what kinds of questions are they asking the ChatGPT based tutor? All of that gives us really useful information to understand where the student is at, and we can leverage that in a useful way. And so in one arm, we basically gave students kind of a standard homework, right? Like 15 problems, 3 of each difficulty, ascending, so on. And in the second arm, we made it an adaptive homework. So we tried to understand, like, oh, are you struggling? Let's do a couple more easy problems to practice before we move on to the hard problems. Oh, you've already mastered this concept. Don't bother doing any more of those easy problems. Let's just skip straight to the hard problems, right? So this is the ideal of what we want to achieve with technology, like as an educator. As a teacher, I'm teaching to the 33rd percentile of students typically. And my best students are really bored, and the students who are below that are confused. And so it's very difficult to kind of tailor or target how we instruct when we're doing this one-to-many kind of teaching. But with this kind of personalized homework, we can actually, if we can just figure out where each student is at and we help them practice exactly where at their level, then you might really be able to unlock a lot of learning gains. And then at the end of this 5 months, they all came in and took an in-person paper exam. So this is an example. Again, this was a government program, and so it was kind of highly proctored. Kind of think of it like our SATs or something like that. There's no digital devices allowed. And the main result was that we found that the students that got the adaptive homework did better by 0.15 standard deviations. I want to say this is a very strong control. So all students got the same course material, the same AI tutor. It's not like we're giving ChatGPT or not giving ChatGPT. Everything was the same. The only thing that changed is whether we gave them a personalized homework. And just by using that personalized homework, we were able to significantly advance their learning. We found that these gains are actually larger for beginners and students at lower tier schools, so generally those with less access. So it seems to indicate that it could actually reduce inequity in access to education, which is sort of what we were hoping would come out of this technology. And the mechanism we basically see is that students are engaging more. So all students don't do extra homework, right? Everyone does exactly the 15 problems that they were asked to do, except for like 1 or 2, superstar students. Everyone tries to do the bare minimum, and that's just a constraint you have to kind of deal with. But we find that the reinforcement learning group or the personalized group had a much higher chat quality. So we're seeing much more productive use of AI, partly because they're answering problems that are tailored to their difficulty level, so it kind of matches where they're at. Okay, so I went on for a while, but I think just to kind of wrap up here, we need to be intentional about achieving human AI collaboration. I think a lot of it has been, oh, if we just get people to adopt these tools and they use them, everything's going to work out great. And I don't think that's true. I think the AI tools have to be designed around human usage. And humans also have to be trained, or their workflows have to be built around the AI tools. If not, we face these fundamental challenges from skill atrophy and incentive misalignment. But better tooling and mechanisms can help. So I don't mean this to be a pessimistic message. I mean this to be more of like we need to put more effort in order to actually get the outcomes that we want to get from human AI collaboration, because historically we haven't seen positive outcomes, but I think there are real gains that can be achieved if we are intentional. Let me stop here and I'd love to take Q&A.
Amazing. Thanks so much, Hamza. God, that's so interesting and so topical. I mean, yeah, massive claps all around. I mean, there's just like, yeah, so much to digest there, but I think we all relate to the balance of how we use AI, how it doesn't quash our brain. I think particularly with young people, I mean, I've got two young children, I'm really in sort of looking at this, but also like, 2025, our brain's still developing, like the impact that like will have on your brain in terms of just letting a machine decide like the problem, the power, the struggle, the mental struggle, like I can just offload that. It's super interesting. um I was just interesting, I'm just gonna let a few more people answer, add some questions. You talk about this kind of like productive struggle as one of the key areas to try and like I guess preserve. And if we, so in in irrational labs, we talk about key behaviors and what is the key behavior that we're trying to influence, be it by dialing up benefits, dialing down barriers. What is it that we're trying to like change within a key behavior?
Yeah.
If we think about that productive struggle as a key behavior, if you can, like, what would you say might be some of the most effective interventions that could kind of keep people in this struggle rather
Yeah.
than them defaulting to AI? Because it's so easy to be like, oh, I'll just ask AI because it's just too easy, isn't it? Are there any things that you can do to kind of like put up actually like a barrier in many ways?
Yeah, I think that's sort of what we try to do with like I mean both like giving students like a hard problem like
Yeah.
or in the trying to find the slide. Like there is an optimal move here, right? So basically we're saying like, oh, there is a good move here. I think here we didn't base it on the zone of proximal development, but I think if we did it again, like we would try to understand, is this a position where a student thinking would really help retention? And then that's when we tell them, hey, maybe you should think more here, and we don't give them additional assistance, right? And I think that's also a communication issue because every student has a phone and they could go and
Yeah.
ask for help on ChatGPT if they wanted to, right? So I think there's also an incentive alignment there where we tell them, hey, we're not trying to give you more homework or more work to do. These are the places where we think that you could learn a lot by creating this productive struggle and improving retention. And so I'll actually just give you maybe less homework even, but it'll be tailored to your level. And then, it's in this zone of proximal development for you. And make an effort here, right? And that's sort of the best we can do. To some extent, students who want to cheat can always cheat, but I think communicating the necessity, because a lot of the work feels like drudge work, right? Like even in chess, like a bunch of people told us there are these easy moves that just take a lot of effort for me to try and figure out because I need to look 7 moves ahead or something. But there's really nothing interesting going on there, and I don't want to waste time doing that. And I'd rather have the AI do that. But when there's a really clever tactic, that's when I want to think about it, right? And so
Mm.
distinguishing what's really useful for learning and what's not, and tailoring that, I think is would be useful.
Yeah, super interesting. Okay, all right, brilliant. All right, well, I will turn to some of the questions that we've got here. So Alison, I don't know whether you can come on mic. In Italy, you've got a question about the framework and what we should keep human. I don't know whether you're brave enough to come on camera or even just come on
Yeah,
mute.
I'm here.
Oh, amazing. Great. Okay.
Yeah, are you able
Ask
to
a
see the
question.
question or should I read it?
Yeah,
Uh,
do you want to just ask the question?
yeah, sure. So,
Amazing.
I really like thinking about, when we make choice about when to use AI, what should be fully human,
Mm-hmm.
what should be augmented with AI, which is what you're discussing here, and what should be totally replaced by AI. But I
Yeah.
also find there's so much disagreement about what goes in each category. So I
Yeah.
just gave the example of like I love writing, and the idea of delegating writing for me is delegating thinking. But so many people disagree with that. So I know it's kind of a weird question, but if you have any thoughts on that.
No, this is a great question. Actually, one of my colleagues is Ethan Malik, and he's kind of a big influencer in this space. And he has a very popular blog, and he uses AI for everything. He's always telling people to adopt AI in every area, but he actually has a big thing about how he doesn't use it for writing because that's how he synthesizes his thoughts, and he thinks he can do it much better than AI as well. I think it's hard to answer like so there's the immediate question, which is like, what is AI good at and what is AI bad at? So like, I think it's bad at writing, and therefore I should, we should delegate this, or we shouldn't delegate that. But I think there's also the journey itself and how it impacts the human, right? So Terrence Tao had a recent quote about, we used to hike and get to a spot, and now you can get flown into the end destination. I'm butchering the quote. But if you get to the end destination, that doesn't mean anything because the whole point was the journey or hiking the way to that destination. There's nothing special necessarily about the destination itself. And so you've lost all the fun of it. So I think what I would like is for humans to sort of understand what parts of their job like also give them joy, and help them think through things and, are good skill builders for them so that they can make informed decisions about what to delegate and what not to delegate. And when I started using AI myself personally, I didn't realize that a lot of the things I gave it were things that I really enjoyed doing. Like, I would have it work out like kind of easy algebraic math, which is just more efficient, especially if you use the advanced tools. But then I realized working it out for myself by hand actually gave me a lot of intuition about what to work on next. And so when I delegated that, I actually couldn't think about problems with the same creativity and insight that I used to, right? So I think we're looking at a lot of these short-term effects and saying, oh, AI crushed this benchmark and it did really well on that metric, and like humans did this. But there's like this longer term effect, right? And we need to like measure that to even understand where we delegate what. So it's not really an answer. It's more of like, I think it's just more questions to be answered.
No, that's awesome. Thank you.
Oh, amazing. Thanks so much, Alison. And I know we've got a couple more questions, but someone's got their hand up and I just thought we just jump to them. And Shamam, do you want to just if I've said that correctly, do you want to just ask your question?
Yeah, I'm happy to.
Great, thank you.
So quick question in terms of your point around, especially like, hey, the removing access to AI can kind of like create a negative effect once you have that companion no longer available. So from a 10,000 hours or attention under learning kind of like mechanism, one of my kind of worries about introducing AI is how we are basically taking away the intuitive judgment and training that just the learning process creates.
Yeah.
So how are we, like, is there a way for us to build context into the AI? Like when you're thinking about guardrails for a more professional kind of like workforce, how do we actually do effective guardrails, I guess?
Yeah, this is a great question. And I think this is also like another exciting kind of research direction we're trying to pursue is like trying to build a science of guardrails. So right now, a lot of guardrails are fairly ad hoc, and they have very different, like people have studied that LLM behaviors are very, very different as a function of those guardrails. So there have been just really cool studies showing that like depending on the guardrails you put into the AI agent, like you get very different equilibrium behavior. There was a fantastic Mashable article series by Chase, a journalist I really like, about how she pretended to be a student and worked with all three different AI tutors, Claude, Gemini learning mode, and ChatGPT learning mode. And she got, very different amounts of help, very different kind of feedback, and it was a frustrating experience in kind of different dimensions on all three. And I think so right now we've sort of just been very ad hoc about it. I think part of the challenge here is measuring both, I mean, I guess to Allison's point, not just the short-term effects, but also like the longer-term effects on how we are affecting the human productivity and the human AI collaboration. I think we haven't studied this fully. What we've seen in early work is that tailoring the guardrail based on the person can help a lot. So, like for different people, for some people, they want to get less help. For some people, they want to get more help. For me, for example, I actually, like while I'm editing an essay with ChatGPT, I don't want it to edit my edits, right? I'm like, this part I'm happy with. Please don't touch it. Like, please only fix this part, right? Or like, give me comments or make minimal edits. You can't tell it to do that right now. I mean, you can tell it, but it still rewrites the whole thing on the canvas. And so it's just not built, I believe, for collaboration. And we're trying to patch it on top using a system prompt or these guardrails. But to some extent, I think there's also a ton of potential for fine-tuning these models so that they're better built for collaboration. Don't tell a high school student who's already written a perfect Like this is what Chase was looking at a Mashable article. They are studying for the New York State Regents exam, and they have a essay response that's going to get a perfect score according to the rubric, and then they send that to Gemini, and Gemini still makes corrections or edits. That's not great for a student to see, right? Because you're taking away their voice now. You want to help them when it's actually meaningful towards the outcome that you're looking for. And I think it's the same thing in the workplace. You don't want to overwrite what other people think. You don't want to take away their voice or their inputs. You want to help in places where there are genuinely missing gaps, right? And it's not built to do that yet. It will either rewrite the whole thing, or it will, not give you much feedback, right? And there's sort of like this trade-off. Ava,
Amazing.
sorry, go ahead, Rosie. Sorry.
No, so amazing. Thank you so much. That's super interesting. We've got three more people that have put in questions. Eva, if I can come to you last, if that's okay. Just so I can go in order. So I've got Tanvi here in Boston. I don't know whether you're happy to come on mic or I can say your question if not.
Yeah, I'm here.
Excellent.
Hi, Hamza. Thanks
Great.
for the great presentation. I was curious about this one learning that you mentioned in the study with the students in Type A about
Yeah.
the students in the reinforcement learning track had better chat quality. And for someone who's like building chats and also like experiences and trying to measure what it means for someone to do well,
Yeah.
that's like how did you measure that? What is good quality? What it looked like?
This is a very good question. And I think it's kind of challenging to measure this.
Yeah.
And also, once you come up with a measurement, they game it, right? So it's like very hard. So we tried a bunch of different things. And then we had basically some metrics. The details are in the paper, but we had some metrics
Mhm.
looking for whether students were doing like answer seeking behavior or they were trying to, actually build an understanding. And all of these were based on LLM judges,
Mm.
which again can be very fragile, like especially if you make that the policy, then people can game the LLM judge. But for this study, like we just kind of hand labeled a bunch of conversations and then fine-tuned a classifier. But we basically were looking for students that were not just saying fix my code, but rather like trying to understand what their conceptual gap is. And we found that when students were in the RL group, they basically had less answer seeking behavior.
Got it. No, that's interesting. And that's what I was hoping for, that's like focused more on certain behaviors
Mhm.
than say other stuff like, I don't know, like token usage or how efficient they were. There's like
Oh, no, no, no. Yeah,
like,
we don't care about. We've generally found that in prior studies, or actually a new one we're writing right now, we found that the number of messages, like a lot of people look at the length of the conversation or the
right.
number of messages sent or the time between messages. We find that that's actually not productive because, like, if you are seeking an answer and the chat has a guardrail, these are guardrail chatbots, they won't give you the answer. Then you have students who are like, "What's the answer, bro? What's the answer, bro? But tell me the answer, bro." And then they start trying to jailbreak it. They'll be like, I have cancer. My mom's gonna kill me if I don't pass this exam. None of these are like
Oh my
useful
God.
chats that are I would qualify as high quality productive AI usage, right?
Right.
And they're kids, so they do all kinds of nutty things. And I remember at some point it looked like all the students had cancer because someone had figured out that if you say that, then it's more likely to give you the answer and bypass the guardrails. So they do all kinds of adorable, cute pranks. Um, we try very hard not to have those reflect as high quality chats. That's partly why we have the human annotation. And the tricky part is they keep coming up with new things. Like they're very clever at that. Right? I'm like, if you put that
Sure.
effort towards learning this material, things would be better. Like,
Exactly. Kids scare me these days. But no, that's great. Thank you, Hamza.
That's so interesting. I love that AI is like registering when there's a sense of urgency. I'm sure it will like catch on to that very soon. Okay, great. Let's go to Rachel in San Diego, who's a product designer. Rachel, do you want to come on? Do you want me to say the question?
Oh, I can
Thanks
come
for
on.
attending. Excellent.
Hi, thank you so much for an incredible presentation. So I'm a product designer. I really love this concept of productive struggle. I think that's a
Mm.
term that we're missing in our industry. And I mean, obviously, my job is to make processes easier for users. We're trying to create the best user experience possible.
Right.
But we're missing terms, I think, like productive struggle in like our day to day. And I'm wondering if you can kind of shed some light on how you would infuse productive struggle in my kind of role, where again, I'm trying to make a process easier, more
Right.
efficient for users, great user experience. And for context, I'm in the healthcare staffing industry. So, like users applying for jobs, for example, like a basic example. Like, how would you like look at productive struggle in that type of a lens, a designer lens?
That's an excellent question. Yeah, so I actually, my interest is also in healthcare. And I think this is actually the scariest place because people just accept answers. And it's not that we want them, I think here it's less about productive struggle and more about like, you know, engagement so that like the shared decision making that I was mentioning earlier, that we really want people to like express their preferences, understand their choices. And again, that's struggle, right? That's work. But we want that to be lead to better out. We believe that that will lead to better outcomes for them. Sorry, I'm trying to pull this up. Yeah. So one of the things we're trying to do is try to actually collect information from people on whether or not their goals are being met, whether they are actually taking the time to express their preferences. Like if it really alarms me when people have like a very significant health-based chat and they're not, asking questions and, expressing preferences, right? Like if you're asking like, oh, like I have conversations with ChatGPT all the time about my kid. I'm like, oh, like this diaper rash is like cream is not working and like, what else can I try? And then, I give it all this information about like, the my daughter and her health condition or like so that it can make the right answers, and often we don't see that happening. So I think a lot of this can be solved by the the chatbot actually asking questions to the users like what are you
Mm.
worried about? Like, what are things that are relevant to this decision? Like, what does your social support system look like? I haven't done too much on staffing, but for staffing, I might guess like, what are your hard constraints and what are your soft constraints? I mean, staffing is such a challenging problem because you have the people who like, will like try really hard to protect certain pockets of time that are actually malleable and other people won't. So I think we can actually solve much better problems if we actually ask people like what are your hard constraints? How much value would you put on this time being taken, right? I think with natural language, we have the opportunity to build a much better model of the world and everyone's preferences so that we can actually give people much better answers. But if we do it in a crappy way where, they just answer the question they're given, then I think
Mm.
we can actually end up in a worse position than if we had, humans collecting that information because at least then they can, put in their domain knowledge.
I love that. Okay. All right, thank you. I'm going to take that back to our team.
Thanks, Rachel.
Amazing. Thank you for these great questions. Eva from the Rational Labs has got some great questions. She wants to hear more about a few things. Eva, are you still about to ask your questions?
Yeah, been happy
Excellent.
to. And I will try to limit it to one or two instead of the five that I have written. Thank you so much for your
Great
time.
points.
So interesting. And one thing that it brought up for me was I used to work in a fasting lab around like rewards processing and cognitive load. And one thing that I was wondering is just if there have been studies or if you've looked at sort of like how much cognitive overload or cognitive load or top end of day versus top of day impacts our sort of spontaneous reliance on AI and moments that we use it more for like learning and in more thoughtful ways versus using it just to get the answers. And if there's interesting insights there that you could share.
That's a fantastic question. I actually don't know the answer to that. We have not looked at cognitive load. I think maybe the closest we've come is when we looked at the chess study. We do find that when there is more time pressure, so whenever there's sort of a bit of a scarcity mindset, that's when we're like, all right, there's a deadline, or like, my kid's crying, or like whatever, we're more likely to offload to AI. We haven't been able to measure that in most contexts, but in the chess context, we did see that whenever, they felt a lot of time pressure, then they were more likely to offload and then not spend enough time thinking, and then they were more likely to blunder after that. Um, I think there was that famous kind of MIT study on like your brain on ChatGPT where they measured kind of people's brains. Uh, I don't know what it's called, but they did some sort of brain scan, I think. I'm not a neuroscience person. And they saw that generally people tended to offload, and then they had trouble kind of engaging back. To me,
Yeah.
that's the real problem. That
Yeah.
when you make a choice to offload, it becomes even harder for you to get back on track later. It's kind of the same when behavioral science principles, when people are looking at a diet, like when you fall off the wagon, it actually becomes much harder to get back on the wagon because you already fell off, right? Um, and that's the friction that you need to kind of address, right? And so my perspective on that is we should try very hard to not get people fall off the wagon in the first place. And then we should work really hard to like not make AI assistance easy. And with students, it's the same thing. Like now they feel stupid because they cheated on the first problem set, not cheated, but like, used too much help. And now they're behind and now they're worried about looking stupid. And so they are less likely to ask for help. And so it just gets the gap kind of widens, right? And that's what we're seeing. We're seeing more and more disparities. And so anyway, I think the cognitive load, I think that's a great question. I think it plays into that, but I haven't studied it personally.
Yeah, I think cognitive load and also just like baseline self-control that people have too in different areas and probably perceived expertise in those areas would probably be interesting to study. And
Yeah.
then I can not ask the second question if we want to give it over to, I think Nabil actually had a very similar question to something I was going to ask. So maybe I will like let him ask it and not take up more of your time, but super fascinating. Thank you.
Feel free to shoot me an email if you have any questions. I would love to chat more.
I will definitely take you up on that. Thanks.
Great. Thanks, Eva. Yeah, let's go to Nabil as the last key question, and then feel free to obviously reach out to Hamza. I'll share her LinkedIn with you so you can ask her more questions, and obviously reach out to us if you've got any other questions as well. But yeah, over to Nabil.
Yeah, I'm just gonna read my question because it was even confusing to formulate. But in work cultures built around velocity and output metrics, the system itself seems to institutionalize the drift toward the easy out. So it's just like we're getting pressure to move faster, velocity, all these things, the ideas of what productivity means, the ideas of what efficiency means at an institutional level, like what we're measuring and everything, really
Yeah.
push in a particular direction. I was just highlighting even in academia, the pressure to publish quickly
Yeah.
is a big thing. These like types of pressures, it feels like we need to like be able to redesign how we measure things and how we reward things on an institutional and an industry level.
Yeah.
Similarly, it just feels really difficult to be even able to argue for doing something more slowly or struggling productively. I would just wondering what your thoughts are on this like larger system at play and these forces that you just experience like as individuals operating in a larger social context.
This question is so close to my heart. So thank you for asking. It's like a huge source of frustration, right? Because the metrics are just wrong. And I think they used to be good, reasonable. I guess it was never maybe a great proxy, but it was like a reasonable proxy for the thing we cared about. If you pushed more features in your app, if you like wrote more essays or solved more homework problems, like if you wrote more papers, those were all good signs that you were kind of doing the right thing. And now I think that is no longer the case, right? Like we are actually, so the for academics, like the publication system is sort of collapsing because we're getting so many AI generated papers, and so people are using AI to review those AI generated papers, which sort of doesn't make any sense. You can't really use that to make hiring or tenure decisions, right? So I think we will have to revisit all those metrics and make it more about quality. Like, I don't care how many papers you wrote. Just tell me about the two best ones you wrote. Like, how were they important or foundational to the field? I don't care about if you're a software engineer, how many how many features you pushed in your app. what we care about is maybe that you never caused the code to crash, or you didn't create a lot of technical debt, or that your code was easier for other people to build off of, right? I think we will need to like realign those metrics, and I think it's going to be a very painful process over the next couple of years because whenever like things change, it's like a guinea pig time, right? And it's going to have negative effects on people who are already in the system. But I feel it's inevitable. Like to your point, like this is just not tenable going forward because quantity is so easy to produce and quality is much harder to check.
Thank you.
Amazing. Great. I'm conscious that we've reached time, if not gone over a couple of minutes, but I just want to thank you so much, Hamza, for taking the time to chat to us and just put something on our radar that I think we're all kind of grappling with, and all the questions that were super interesting. And I think this is you can go down a rabbit hole with this, couldn't you? So thank you so much, Hamza. I've just shared her LinkedIn if anyone wants to be friends with Hamza, and obviously be friends with us at Irrational Labs. If you want to work with us, obviously, visit hello@irrationallabs.com or email us, sorry. We've obviously got a newsletter as well if you want to stay on the loop with all of our talks, just like Hamza's, which was brilliant. And Kristen does some fab teardowns, our CEO, so feel free to find her on Substack. But unless there's anything else, I just want to say thank you again so much to Hamza. It was so great. And if hopefully we'll see some of you all again soon at our next talk in May. But otherwise, have a lovely Friday, and we'll see you all soon. Bye, guys.
Thank you so much, guys. It was fun.
Bye.